This isn't just a story about a piece of technology. It's bigger than that. It's really about a fundamental human quest, the quest for memory. This is the story of the hard drive, the machine that taught our computers how to remember.
I want you to just imagine this for a second. What if every single time you turned your computer off, everything was just gone? Every document, every photo, every piece of data just vanished into thin air. Well, that was the reality of early computing, and it was the core problem that absolutely had to be solved. So let's go back to that time, a time of these giant, brilliant machines that were, in a way, just profoundly forgetful.
See, early memory wasn't anything like what we think of today. It was physical. I'm talking about punch cards and paper tape, literally holes in paper, or these massive spinning magnetic drums. They were slow, they were incredibly bulky, and they were ridiculously expensive. You just couldn't build a digital world on that kind of foundation. No. But then came the breakthrough. Scientists realized that if you could magnetize a material in one direction or another, and here's the key part, it stayed that way even without power, well then you could store information. You could create a memory that actually persists. And this simple yet profound idea changed absolutely everything. And that one big idea led directly to this, the invention that would finally solve the memory problem and really lay the groundwork for our entire digital age. The year was 1956. IBM unveils something called the IBM 350 RAMAC. It was the world's very first hard disk drive. And when I say unveils, I mean this thing was a monster. It weighed nearly a ton, a whole ton. That's about the same as a small car. And for all that weight, all that incredible engineering, what did you get? 5 megabytes. That's it. Today, that's barely one high-resolution photo on your phone. The scale is it's mind-boggling when you think about it. But here's the thing, despite its absurd size, the RAMAC was completely revolutionary. Because for the very first time, you could jump to any piece of data directly. That's random access. This wasn't just about storing stuff. This was the birth of the digital file system. The ability to find file C without having to read all the way through file A and file B first. The game had officially changed. Okay, but how does this magic actually happen inside the box? Let's break down the incredible science that took us from that one-ton beast to the little device sitting in your computer right now. The engineering in here is just beautiful. So first, you have these platters spinning at unbelievable speeds, creating this tiny cushion of air. On that cushion, the read/write heads literally fly, just nanometers above the surface. A tiny electromagnet then flips billions of magnetic particles into ones or zeros, writing your data. And to read it back, they use a quantum physics effect called giant magnetoresistance, or GMR, to detect those tiny magnetic fields. It is an astonishing, high-speed dance of mechanics and physics. The secret sauce that makes all of this possible is a property called hysteresis. Now, that's a fancy word, but it's for a really simple idea. It's the material's ability to remember how it was magnetized. Think of it like bending a paperclip. Even after you let go, it still remembers the bend, right? That's the physical property of memory that this entire technology is built on. And to keep track of all those billions and billions of bits, the drive basically organizes the platter like a map. You've got these concentric circles called tracks, pie-shaped wedges called sectors, and cylinders that stack those tracks across multiple platters. It's a super precise addressing system for every single bit of your data. Okay, so we have the core technology. The next chapter in this story is just this relentless, decades-long race to make it smaller, faster, and to pack more and more data into the exact same amount of space. And the progress was just exponential. I mean, in 1980, Seagate crams that same 5 megabytes into a shoebox-sized drive for the first personal computers. Then the 90s hit, and capacity just explodes from megabytes to gigabytes. And by the 2000s, we hit terabytes, thanks in large part to a major breakthrough in physics. You see, for decades, we stored magnetic bits by laying them down flat, end to end. But we were just plain running out of room. The solution? It sounds simple, but it was brilliant. Stand them up. This idea, called perpendicular recording, allowed us to pack bits way, way more densely, leading to that massive explosion in capacity.
And that brings us to today, where engineers are literally pushing the very limits of physics to keep this incredible trend going.
Modern drives are absolute marvels of engineering. We now have something called HAM, that's heat-assisted magnetic recording, which uses a tiny laser to heat a spot on the disk for a nanosecond. Why? So data can be written to incredibly small and stable bits. We're also sealing drives and filling them with helium instead of air. Sounds crazy, right? But helium is way less dense, which reduces friction. That means you can pack in more platters and use less power. It's this amazing fusion of optics, thermodynamics, and fluid dynamics. Of course, the hard drive is no longer the only game in town. The solid-state drive, or SSD, has no moving parts, which makes it much faster and a lot more durable. But the crucial difference, the one that really matters, is cost. Hard drives are still dramatically cheaper per gigabyte, which is exactly why they still dominate for mass storage, in data centers, and for all of our backups. So, when you step back and look at it all, what is the final legacy of this incredible spinning machine? It's really this quiet triumph of so many different fields of science, all coming together in one small box. You have electromagnetism, material science, mind-bendingly precise mechanical engineering, and yeah, even quantum physics, all working together in perfect harmony. Every photo you've ever taken, every document you've written, it really owes its existence to this technology. It's a story about the spinning disks that learned how to store thought itself. So we've gone from holes in paper to these amazing spinning desks to solid-state memory. The journey has been absolutely incredible. And each step was this giant leap in our ability to capture and store information. So it really makes you wonder, right? What's next? What will be the next way we teach our machines to remember?